Hello everyone, welcome back. In this video, we're going to be using our machine learning tools to do some exploratory analysis of the bike sharing system in Washington, D.C. And what we're going to try to do is we're going to try to analyze what factors lead people to riding their bike more often or less often. And really our focus here is going to be trying to provide explanations. It's explanatory analysis rather than predictive modeling. So depending on where you want to draw various lines between statistics, machine learning, and data science, this may or may not be machine learning. However, we're going to be using the tools that we were using in machine learning. And in any case, it's a very interesting statistical analysis. So to get started, make sure that the bikeshare.csv file is in the same folder as this notebook. And we're going to use the same standard imports we always do, pandas, numpy, matplotlib. We are going to use the bikeshare CSV file, store it in a data frame named bikeshare. And let's take a look at what our data looks like. All right, we got a nice, beautiful data frame talking about all the bikers. The DTE day column is going to talk about what day it is. We have the year, and years are going to go from year 0 to year 1 because this data set was created when it was a new system and it was only 2 years old. Months go from January all to December. Holiday will be either a 0 or 1 depending on whether or not it's a holiday. Day of the week. And then we also have working day. For zeros are for weekends, 1 are for weekdays. Weather sit is going to decode whether or not it's raining. We also have a temperature column. And we actually have several other columns. I'll scroll over here. And now up. Okay, we got the wind speed, the humidity. And what we're really going to be interested in this video for the sake of example is the number of casual riders, which is in this casual column. The last one that was cut off is count, which is the total number of people in the system. So in order to do this, we're going to first convert the DTE column into a proper date time column. So we're going to import the date time module and say bike time DTE is going to be converted to the date time format. This is just going to help us make a nice little plot. And now to make our plot, we say fig x is equal to plt dot subplots 1. X dot plot is bike share DTE day bike share casual riders. And let's take a look. So already we can actually see some interesting trends. One is that it looks like more people were riding it in the second year than in the first year overall. We also can see that there's some seasonality where depending on the month it's cold out, so people don't like to ride their bikes outside. And we also see some kind of like rapid up and down patterns, which you might guess correctly, by the way, that this probably has to do with days of the week. So there's kind of a long yearly cycle and then like a short kind of weekly cycle. So with this very simple visualization, we already got some info, but let's see what more we can learn. So I guess that these rapid up and downs might have something to do with weekends versus weekdays. So let's try grouping by weekday. So we say bike share. Then we use the group by method, working day. And we want to then predict the list containing the list of the casual. And then in each group, we want to look at the average. So we take the mean. Okay. So what we can see is that on average, on a working day, when working day is equal to 0, which is the weekend, there are more than twice as many riders as on the weekday. Just shrinking the font just a little bit so that way we can see better. Okay. Now what happens if we also break things down by month? So here we're going to use almost the exact same code. But in addition to working day, we're also going to group by month. And in our data frame, month is spelled with no O because nobody likes the letter O. And we get something which is kind of hard to read. We can see we got a table. And I mean, it's not terrible, but I think we can do better. And when I claim we do better, I claim we can make a plot, and our plot's going to be beautiful. Okay. So what we're going to do is we are going to group our bike share. M is equal to bike share dot group by working day, month, need their quotes, casual dot mean. And now let's make a plot. plt.subplots1. And now we're going to use a line plot, x.plot. And okay, now we need to put on our thinking cap. We're going to make two plots, one for the weekend and one for the weekdays. And in the first plot, we want to look when the working day is equal to 0. So we say m.lock 0. And then for our next one, we're going to do for the weekend. So let's do it at m.lock 1. Alrighty. So now we see we got two different line graphs. And we're going to want to tell which one is which. So we should add in some labels. So we could say label EL, weekends. And then this one's going to be labeled equal to weekdays. We're going to want to have a legend. And we're going to set the X label equal to month. And then Y label equal to number of casual riders. All right. So we see we got the blue. That's the weekends and the weekdays. We got the months on the x-axis and the number of casual riders on the y-axis. So we got some nice visual patterns. Let's go further. Now let's do grouping by working day, weather sit, and month. So we've added in one more thing, and now we're going to make a really pretty picture. So here what we're going to do is we're going to say fig x is equal to plt.subplots 1 and 3. We're going to make a 1x3 grid for different weather situations. Fig size equal to 10.3. And we're going to share the y-axis, share y equal to true. And okay, so in order to make a different graph for every weather situation, we're going to encode this via a dictionary. So we're going to say weather codes is equal to the dictionary with 1 being equal to clear, 2 equal to cloudy, and 3 is equal to light precipitation. These weather codes can be found by just looking up the documentation of the data set. Alrighty, so now let's actually make our plot. So we're going to say for W in weather codes, for weather codes is a dictionary, so it's for W in weather codes dot keys. So we're starting from 1, but we actually want to start at 0. So we say x of W minus 1 dot plot m dot lock 0 dot lock W label equal weekends. And then we're going to do the same thing with the weekdays. Notice that we're using hierarchical indexing. So the dot lock 0 means that we're restricting to either weekends or weekdays if it's dot lock 1. And then from there, we then need to look into the weather situations, which is the next level of granularity from the group bys of working day, then weather sit. It's hierarchical indexing. And then we say x.w minus 1 set title is going to be equal to weather code W. So here we are using the codes from our dictionary. And then let's make a legend. And we can just put that on the first one, x.0 legend. And it says weather code is not defined. Ah, yes, there should be an S there. Alrighty, so now we see we've got 3 beautifully aesthetic graphs. And we can see that on clear and cloudy days, cloudiness doesn't make that big of a difference. Maybe a little bit on the weekend, I don't know. But when it's raining, no one wants to ride their bike in the rain. It's terrible, thoroughly unpleasant. Also kind of dangerous. Don't do it. So that's kind of our exploratory modeling. Now let's try to do some machine learning tools. So we're going to focus in on certain columns, and I've written these out for you. And what we're going to do is we're going to look at the columns of casual riders, the month, the weather situation, the working day, the year, the temp, the humidity, the wind speed, and whether or not it's a holiday. And then we're going to make a data frame by looking at those columns of our bike share. So we're getting close to being ready to process stuff. But one of the issues is that month goes from a number to 1 to 12. And now we're going to do something which is a little bit tricky called get dummies. So what get dummies does is it, rather than having a single column that is either 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11, or 12, this is going to have 12 different columns. And column 1 is going to have a 1 in it if it's January and 0 otherwise. And column 2 is going to have a 1 in it if the month is February and a 0 otherwise, and so forth. So to check this out, what we're going to do is we are going to say model df equals pd dot get dummies model df columns equal month. And now we can look into our new data frame. And we see we've now got 12 more columns, 1 for each month. And these are what's called dummy variables, or sometimes also called a one-hot encoding. So next what we're going to do is we're going to separate our model into our predictor variables and our target variables. So we say x is equal to model underscore df casual axis equal to 1, and y is equal, model df dot drop casual, and then y is going to be model of df casual. Alrighty. So now we've split up our data into the target and the predictors. So what we now need to do is we need to try to actually make the predictions. And we're really focusing on something which is going to be really interpretable and explanatory. So we're going to use linear regression. So we're going to say from sklearn linear model, import linear regression. LR is equal to linear regression. LR.fit x, y. Alrighty. And now let's see how well we do. All right, we got 73. So we know that 1 is basically perfect, 0 is useless. And so this is quite a simple linear model. And 73 is a lot closer to 1 than 0, so this is pretty good. And now let's also try to visualize our predictions. So for this, we would say bikeshare preds is equal to lr.predict x. Fig x is equal to plt.subplots 1. We're going to make it nice and big. 10.7 should be a tuple. And then we're going to make 2 plots, one for the real data and one for the fake data. So we're going to plot DTE day against bikeshare casual. And let's make another plot. So I'm just going to copy and paste this so I don't make a typo. Or it's less likely that I make a typo. And we're going to replace casual with the preds. And now let's take a look. Alrighty. We see we've got an orange line which is meant to approximate the blue line. And in order to be able to tell which is which, we should add in a label. This will be true. And then this will be the prediction. Add a legend. All right, this doesn't quite fit on the screen, so let me just make my screen a little bit smaller again. All righty. So I think that the fact that we did this using a single model, it looks pretty good. It seems to maybe underestimate a little bit the real zigzags of the weekly fluctuations, but we're clearly learning a lot about our data. So I think this is pretty good, actually. And the last thing we're going to do is let's try to then interpret what factors do what. And so to do this, what we do is we say PD dot data frame variable will be the x dot columns. And coefficient is going to be lr.coef underscore dot round 2. This line here seems kind of strange, but it'll make sense once I press enter. So what we have when we use this dictionary to create a data frame is we have a bunch of variables and we have their coefficient and their linear models. So a positive coefficient means that this variable is positively correlated with the number of casual riders, and a negative negative coefficient means that this is inversely correlated. So for example, we can see that on a holiday, people were much less likely to ride their bike because this number is negative. But on a warm day, people were much more likely to ride their bike because this number here is positive. And similarly for all of the other numbers. Now, if this was our job, we wouldn't be done. We would keep going. There's many must steps, and we would keep trying to improve our model, visualize, transform, and then come up with things that we can communicate to other people. But I think we did a lot of good work in this video, so here's where I'm going to stop, and I will see you again next time.